Welcome back to the 360 Degree Data Podcast. If you're a software engineer right now, you probably had this thought. Am I learning the right things? There's so much noise out there. Learn Python, learn LangChain, learn vector databases, learn fine-tuning, agents, MLOps. It's exhausting. So today, we are cutting through it. 4 real paths software engineers can take in the AI era. And for each one, the actual skills and the technologies worth learning. Let's look at what most people are doing. Most engineers right now are doing one of two things. Some are panicking, watching AI write code and quietly updating their CV. Others are pretending nothing has changed, still coding the way they did 3 years ago, assuming experience alone will protect them. Both are wrong. The role isn't disappearing, it's reshaping. And the engineers who reshape with it are going to be in extraordinary demand. Let's look at the shift most people miss. Here's the key idea. AI hasn't replaced engineering. It's raised the floor. What used to make someone a good engineer, writing clean functions, remembering syntax, building basic CRUD apps, AI can do most of that now. So the bar moved up. The new value isn't in what you can type. It's in what you can decide, design, and be accountable for. Let's look at path 1, the AI-Augmented Engineer. You stay a generalist software engineer, but you become exceptional at building with AI tools. Here's what to actually learn. Get fluent with coding assistants like Cursor, GitHub Copilot, Claude Code, Windsurf. Not just using them, knowing where they fail. Learn agentic coding workflows, multi-step tasks, code generation across files, automated refactoring, AI-driven test generation. Learn prompt engineering for engineers, how to brief an AI on a code base, how to give it the right context, how to spot bad output, and learn AI-assisted code review, tools that catch security issues, bad patterns, regressions. The goal isn't that AI helps you. It's that you ship 2 or 3 times more at higher quality than engineers who don't. This is the safest path and the most underrated. Path 2, the AI engineer. It's a different role, different skills. You move closer to the model itself. Here's the actual stack to learn. Languages, Python first. It's the lingua franca of AI. Then the core libraries. LLM frameworks, LangChain, Llama Index, or the new lighter ones like Pedantic AI. You don't need all of them. Pick one and go deeper. Retrieval Augmented Generation or RAG. How to give models access to your own data. This means learning vector databases like Pinecone or VV8, Chroma or pgvector if you want to stay in Postgres. Embeddings. How text becomes numbers. How similarity search actually works. And then agent frameworks like LangGraph, Crew AI, or building your own with the model APIs directly. Evaluation, and this one matters. Most engineers can build an AI feature. Few can prove it actually works. Learn how to test LLM outputs systematically and learn the major model APIs like OpenAI, Anthropic, Google, Mistral, and the strengths, costs, and quirks. You don't need a PhD. You need to be excellent at integrating intelligence into real products. Path 3, the data and the ML engineer. This path goes deeper into the foundations. You're building the plumbing that makes AI work in production. The stack here is bigger, but well-defined. Strong Python at production quality. SQL, still the most underrated skill in this whole space. And data engineering tools, dbt for transformations, Airflow or Perfect for orchestration. Spark, if you're working at scale. Cloud platforms, pick one and get deeper, like AWS, Google Cloud, or Azure. Every serious AI workload runs on one of them. And MLOps, the operational side. MLflow for experimental tracking, weights and biases for monitoring, Kubernetes for serving models at scale, future feature stories like Feast, and then model serving frameworks, VLLM, Triton, or Bento ML. Learn how to deploy a model, monitor it, retrain it when it drifts, and roll back when it misbehaves. There are far more model builders than there are people who can operationalize them. This path is wide open. Path 4, the domain plus AI engineer. This one is quiet but powerful. You take a deep knowledge of a specific industry, finance, healthcare, logistics, or legal or manufacturing, and you pair it with strong AI skills. You're not the best AI engineer, and you're not the best domain expert, but the combination is rare. What to learn depends on your domain, but the AI side is roughly the AI-Augmented Engineer stack, plus a working understanding of RAG and agents. The real skill is translation, knowing which problems in your industry AI can actually solve, knowing which ones it can't, knowing your domain's regulation and constraints, and speaking both languages, the technology and the business. This path has the longest shelf life because deep domain knowledge doesn't get disrupted overnight. Now, let's look at the skills underneath all 4. No matter which path you take, 3 skills now sit underneath everything. 1, fluency with AI tools, not just using them, knowing where they fail. Number 2, judgment, knowing when to trust an AI output and when to push back. Number 3, communication, explaining technical decisions to people who don't code. The engineer who can translate between machine, code, and business is the one people build teams around. What this really means? Here's the bigger truth. Software engineering isn't shrinking, it's splitting. It's splitting into engineers who use AI to multiply themselves and engineers who don't. The first group is becoming more valuable. The second is being quietly outplaced. The choice isn't whether to upskill. It's which version of an engineer you want to be in 3 years. So as I close, here's the takeaway. Don't try to learn everything. Pick a path. Go deep on its tools. Stay curious about the rest. The engineers who thrive in the AI era won't be the ones who can outcode AI. They'll be the ones who can outthink with it. Thanks for listening to the 360-degree Data Podcast. And here's one question to leave you with. If you had to bet on one tool, one framework, or one skill to carry your career for the next 10 years, would it be the one you're learning right now? I'll see you in the next podcast.